Hi everyone, this is David Blakey, and the title of this video is Python Objects and Attributes, Arguments and Return Values. We'll be talking about probably the most basic concepts in Python, so you may find that this video contains information that you already know, in which case you're certainly not required to watch it. It's only just to clarify things, in particular for those who are new to computer science, or those who just want to get a better handle on what we mean by objects and attributes. And we'll also go over arguments and return values. That is, what happens when we call a method or a function in Python, and what are those, and then what it means to pass arguments. So we could list that out here. We're going to talk about objects. What is an object? What is an object in Python, really? What is an attribute? What does it mean to call an attribute? That would be a method or a function. And then finally, well, let's see. And then finally, what is an argument and what is a return value? So it's all mostly contained in the title there. All right, great. So let's begin. I'm going to begin by just opening up, or I already did open up, but I'll open up again, just starting from a terminal session, which, as you know, you can start with on a Mac or on Linux or even on the PC. You can type Python and be presented with this this interactive prompt. The interactive prompt allows us to type Python code straight into the prompt, and then we can retain values that were set. So anything we do type is sort of part of a kind of a dynamically created program that's really running as we speak. We can work with the different values that we have here. When we talk about Python objects, we really talk about almost any entity in Python is an object. Things like integers, strings, that's an object, a list, all the basic structures that we've talked about being the core data structures. But in addition to that, there are other types of objects as well. For instance, a subroutine. We haven't talked about subroutines at all yet. But a subroutine is an object as well. We can call a subroutine this way. We'll be talking about these user-defined subroutines in an upcoming session. But even a subroutine is an object. And with any type of object that we have, we can check its type using the type function. So here's the type of a string. It says type str. As you can see, though, we can even put in the name of a function that we created, and it'll tell us it's a type function. Type is a keyword meaning, sort of what sort, obviously, and it's a keyword in all languages to denote, sort of the identity of an object. What is the identity of this function? It's a function object. So everything is an object in Python. There are certain exceptions to that, of course. If we have a list like my list, and we say for I in my list, we know that the list is an object. It's a list object. But the for construct is a special entity of its own. It's a logical structure. The if statement, the for statement, later on we'll look at the while statement. These are all conditional statements that are just part of the logic structures of Python. And they don't really qualify as objects, certainly. But almost everything else in Python. And then operators, you have things like operators, like the plus sign. This is more of a syntactic synonym for what's actually a method. But we'll get into that later. Overall, we can say that almost everything in Python is an object. And we can also say that objects have attributes. We can look at the attributes of any object by putting it in the dir. You get a list of strings that are the names of the object's attributes. If we have my string, for example, no, I didn't find my string. So let's say my string equals hello, and we do a dir my string. You can see that there are a number of attributes available from my string as well. This is a list of names of attributes. And how do we use these attributes, and what are these attributes for? Well, every object has a set of attributes. Any object of any type, really, has a set of attributes that are associated with it. And so we can always know that any object we work with has attributes. Whether or not we're expected to call these attributes is another matter. But we do want to understand that central to Python, the central Python syntax, not unique to Python, but central to Python, is this object.attribute syntax, object.attribute. Now, in the case of lists, or strings rather, like MyString, we have this set of methods or attributes that we call callable attributes. For instance, MyString upper, which returns a new string object with the letters of the string uppercase. This is a particular type of object that is callable. When we say that an attribute is callable, we call it a method. But what we can also say is that it does something for us. And we can also identify, excuse me, a callable attribute in code that we read by the parentheses. You can see that upper has parentheses after it. Not all attributes are callable, but anytime we can use an attribute with parentheses after it, we can know that that attribute is callable and is thus a method, something that we call a method. And a method, or a callable attribute, method, is simply something that does something for us. And what it does really depends on what the designer decided that it should do. And whether or not it affects the object itself, or whether it returns a new object, is really dependent on just sort of what was in its design. If I get out of this and go into, let's say, my favorite test.py, and talk about attributes, callable attributes in our code, we might say upper string equals MyString.upper. This gets us into this idea of calling. MyString equals hello. And then if we were to print upper string, we would get hello. What we're looking at here is first a string object. Then what we're looking at here with the parentheses and the attribute is we're calling a method on MyString. When we say MyString.upper, we're calling a method on MyString. And in the case of upper and most string methods that are meant to modify the string in some way, what we're getting back is a return value. So what you see here when we say upper string equals MyString.upper, it's important to be quite clear on the terminology that we're using here. MyString.upper returns a new string. You can see when we print upper string, you can see that it's a new string. It's a string. And if we were to print MyString, we would see that MyString is unchanged. So strings, which are immutable anyway, have methods that return, they have many methods that return new strings. The concept of returning is this idea that we get back something from a call. Now, it looks a little counterintuitive to have upper string on the left side. You almost think of a method call producing something new. We would see it come out on the right. I don't know why I would think that way, but I do. But that's not how return values work. Return values always appear on the left, and we'll say upper string equals MyString.upper. The reason I think it works this way is that we want to assign an object that's, let's say, produced by upper to a new label. In the same way that we're doing that in the first line. We're assigning a string object to MyString, right, the label MyString, so that MyString, the label, now refers to a string called, a string that contains the values HELLO. Same thing with upper string. MyString.upper returns a new string, and upper string is now a label that is associated with a string object. Both of these are string objects, and one was assigned by really constructing a new string object and then assigning it to this label. The other by calling the upper method, which we know returns a new string, and getting back the new string and assigning that to upper string. So this is the idea of return values. And sometimes we may have arguments to a method. We have another method called find. So we might say position equals myString.find, and let's look for the first L within myString. And if we were to print position, we would get back, I guess, 2. I'm going to have to test this to be sure. Let's try it. Let's say print position of L. This is me testing. And then let's see. Okay, we're going to print those two, and then we'll say position of L. Let's open up a new window and see what we get. Test.py. Well, I got a. I think I didn't save it. I think that's what happened. Let's try it again. Okay, hello, hello. Position of L is 2. Let's check it out. 0, which is the first element. E, the second element, which is index 1. So H is index 0, E is index 1, and L is index 2, which is why when we print, we see position of L is 2. You can compare that to what we've got here. Position of L, print position. Now let's look at this line, because this is what I want to get across to you. Find takes an argument. You can see that we've passed a string object to find. You can tell it's a string object because it has quotes around it. Find takes a string object and it returns, well, what type of object does it return? An integer. MyString.find takes a string argument and it returns an integer which represents the position of that string within the string itself, myString. Let's see, we can put more than just a letter. We could ask for EL. Where does EL appear in hello? And I'm sure we're going to find out that we'll get back 1 with that. Try it just to see. Position of L, well, position of EL really now is 1. Check it out. 0 and then 1. There's the beginning of the substring EL that is found at position 1 in the string hello. It's all very straightforward. And I'm not so much trying to give you information about find as much as I am illustrating this idea that methods sometimes take arguments. We call them arguments, and they sometimes return values. We call them return values. I want that to be exceedingly clear to all of you because we use this terminology throughout the term. Now, this is not true just of methods. There's another type of entity within Python called a built-in function. It's really just a synonym for another method call, but we'll go into that much later when we look a little bit under the hood in Python. For now, you can just say print len myString, and it should give us, or it should get back really, an integer value representing the length of myString, which of course will be 5. So we could say, in fact, we could say myString length equals. So again, len is a built-in function that takes an argument. Clearly, it takes a string argument in this case, and it returns an integer. The integer is the length of the string, so we can say length of myString. I put these print statements in to be clear. Print myString length. And of course, what we'll get back is 5. I don't need to test it. That's clearly what will happen. But just because I love you, I will test it. So you can see length of myString is 5. Great. So again, I'm not so much trying to emphasize the use of len. Instead, I'm trying to show you that len is a built-in function, and we'll see some others, that takes an argument, that is myString, and it returns a return value. In this case, len takes a string and it returns an integer. We're going to see later on, or actually we did really in the first session, that len can also take something like a list. My list equals A, B, C. And then we could say len my list. And again, just like with the string, my list takes a list and returns its length, returns an integer. You can see that len the function can take more than one type of object. Len the function could take a string. It could take a list. It can take also a dictionary or a tuple, and probably can take a few other things as well. And what we get back is an integer that represents the length of that thing. So if we say length of my list in this case, and we print my list length, we're definitely going to get back 3. Okay, so that's the idea of arguments and return values. So when we talk about objects and attributes, I just want to once again emphasize these attributes can be attributes of any type of object: a string object, a list object, a dictionary object, a tuple object, even an integer object. But there are other types of objects as well, like modules, like the sys module. Let's go back to an interactive prompt. If we import sys and then we say dir sys, we get back the same sort of list of attributes that we see for a string or a list or anything else. This module also has its own attributes. A module is very different from a built-in object, but it has attributes just like any other object. We could probably see that even a method or a function, let's say, a subroutine that we write has its own attributes. Why don't we even try it with dir stir.upper? Our old friend stir.upper, which is a method, if we do a dir on that, we actually get a list of attributes for that as well. And the thing is, upper itself is an attribute, right? Upper is an attribute, but upper isn't just an attribute. An attribute simply points to an object of a certain type. So upper is actually its own object, right, which is a method. We saw that earlier. We can say type stir.upper and we'll get, a method. It'll say method. It says method descriptor, but we won't go into why it says descriptor. But as I say, we can do a dir on just about any object and see what sort of methods are available. As you can see, all of the attributes of this method are special. They have underscores before and after them, what we call special methods. Generally speaking, we don't call these methods directly or really have to think about them very often, but they are there, and they do prove that any type of object, doesn't matter which object it is within Python, has attributes. And we're going to use the object.attribute syntax repeatedly in this course and as you continue to learn Python. Back to sys, when we say dir sys, you can see a bunch of attributes here too. Attributes, as I say, are kind of like variables. They're labels that point to other objects, and you can see a group of them here. One of them I talked about in class recently is copyright. The sys module is a module that gives us a hook into Python. In other words, we can sort of communicate with Python using the sys module. And if I've imported sys and then I say sys.copyright, you can see that we get back a string. Sys.copyright points to a string. It's a string object, and that string object, of course, has attributes, the string attributes. Any object has attributes. Even the attributes of one type of object points to another object that itself has attributes. So whether it's a method, whether it's a string, whether it's some other type of object, attributes point to objects, and all objects have attributes, which sort of makes it sound like we could go on and on and on looking at objects and attributes. And in fact, we probably could. The only thing we need to keep in mind over and over and over again, and just what I want for you beginners to make it, sort of crystal clear, is that almost everything in Python is an object, and objects have attributes. The attributes point to other types of objects like methods or strings, and that every object has attributes. Okay, I think I've said that enough times. Just want to make it clear to you. And thank you for listening, and we'll see you in the next video.